So we're going to find the residues of this function here, 7e to the z squared over 2z plus 3 cubed. So where do we start? Always first place to start is to find the poles. But the slight problem here with this one here, in the form of 2z plus 3, we need it in the form of z of something. So we're going to rewrite this function, making that in the form of z something. So we've got 7e to the z squared over, right, 2z plus 3 cubed. So if we cube this out and forward it and everything, we get 8z cubed as our first term. So it looks like 2 to the power of 3 will have to come out of there. So it'll give us an 8. So if we write an 8 first, and then z, so that's what we want in the form of. So 2z plus 3, if it's a z, it's now 3 over 2. So z plus 3 over 2. So we've halved everything inside here, and then that's cubed. Okay, so now we're going to have a pole. So z plus 3 over 2, so therefore the pole is going to be at minus 3 over 2, because that's when that equals 0, and it's of order 3. So pole of order 3 at minus 3 over 2. So that's our pole sorted out. Okay, as we've got a cubed here, we need to use the derivative formula for when we're finding our residues. So what we can say is residue of f at alpha, so this is our alpha, minus 3 over 2 is our alpha, equals 1 over n minus 1 factorial. N is our 3, so this is our n. So it's i.e. the order of the function here. So 1 over n minus 1 factorial, and multiply that by the limit as n approaches alpha, i.e. minus 3 over 2. Open that up, and then we want the n minus 1's derivative, so d to the n minus 1 over dz to the n minus 1. And then we take the pole, so z minus alpha, and then what's left after that when we've taken that out. Okay, so that's our formula. So let's just break it down with our values. So we know what n is, that's 3, so we can do that for that, that, and then we'll just leave it as what our function is. So that equals 1 over 2 factorial, the limit as n approaches minus 3 over 2, second derivative, our n is 3, so second derivative of dz squared. So, oh, sorry, I just missed out the n on this bit here. So z minus alpha cubed, and f of z. So I'll just write here what f of z is. So if we're taking z minus alpha cubed out of this, a bit like the cover-up method, we could just take this bit out. So we're left with 7e to the z squared over 8. That is our f of z, which we're going to take the derivative of. So next stage, we need to find the derivative of this twice. So the 7 over 8, this one here, we'll just take that out as a constant multiple and take the derivative of this one. Make our life a little bit easier, and then we can put the 7 over 8 back in at the end. So derivative with respect to z of e to the z squared equals, so derivative of 2z, z squared is 2z, and then e to the z squared, that doesn't change. But notice here we want the second derivative, so d2 dz squared of e to the z squared is basically the derivative of this one. So we can see here we've got a product rule. So 2z times the derivative of this one, which we know is 2z e to the z squared. And then we add on top of that derivative of 2z, which is just 2, and then e to the z squared, which stays. Okay, so just break this down. It looks a little bit complicated, but just 2z times 2z is 4z squared. e to the z over 2 plus 2e to the z times 2, sorry. And then let's factor this out. We've got an e to the z squared. Then we multiply that by, we can take a 2 out as well. 4z squared, so take a 2 out of that. That's 2z squared plus 1. And then multiply that by 2. So put the 2e there. So that's our formula here that we're looking for our derivative. So that is basically what this is in our formula. Okay, so we've got all our workings out here. So I've got 1 over 2 factorial. So the residue of f at alpha, which is minus 3 over 2, equals 1 over 2 factorial, it's just 1 over 2. Our derivative of f of z, so our derivative, we've got to plug the 7 over 8 in again. So 7 over 8, 2e to the z squared, so 2e, now our z here is minus 3 over 2, so straight in there with minus 3 over 2 squared, which is 9 over 4. So that's 9 over 4. That's that. And then the 2z squared again is 2 times 9 over 4, which is 9 over 2 plus 1. Okay, let's work through this. 1 over 2 times 7 over 8, that becomes 7 over 16 times 2e to the 9 over 4. And then 9 over 2 plus 1 is 11 over 2. So that's 11 over 2. Okay, this cancel out. So 7 over 16 times 11. So that basically equals 77 over 16. E to the 9 over 4. Okay, and that equals our residue. Oh, sorry, just write that properly. Residue of f at minus 3 over 2. That is our answer. Okay, so using this formula here, that is how we find the residue of this function here, and this is our answer. Okay.